In this problem, we are going to find an equation for the tangent line when we are given a parametric curve. When you have parametric equations, they relate x and y, but through a third variable t. This third variable t you can think of as time. So at any moment in time, this specifies a point in space, and then as t varies, you can imagine that point in space moving along some curve. Our parametric equations are x equals secant squared of t minus 1, and y is equal to tangent of t. We will find the tangent specifically when t is equal to pi over 4. Since we're going to find an equation for a line, it's going to be useful to use the point slope form of line. That's y minus y0 equals m times the quantity x minus x0, where these x0 and y0 are the coordinates of some point that's on our curve, and then m is going to be the slope of the tangent line at that point. So we can figure out the values of x0 and y0 almost immediately. What we need to do is plug this value of t into these formulas for x and y. So when we plug in t equals pi over 4 into our equation for x, we get secant squared of pi over 4 minus 1. And if you numerically calculate this, it ends up simplifying down to 1. So we now know that the x0 value is 1. Let's replace that. Next, we'll find the y-coordinate of the point. The y-coordinate is given by tangent of t. Plug in pi over 4, and we get 1 again. So y0 is also 1 in this problem. Let's replace that. So we have a point that's on our curve. It's at 1, 1. And that's where we're trying to find the tangent line. Next, we need the slope of the tangent line. Once we have that, we're actually done. So, as usual, the slope is the derivative, but it's the derivative of y with respect to x. We don't have y as a function of x, so we're going to have to figure out this slope m indirectly. What we're going to do is we're going to calculate the derivatives of both of these with respect to t. Let's start by calculating the derivative of x with respect to t. So the derivative of this 1 obviously is 0. When I do the derivative of secant squared, I need to remember to use the chain rule. So I get 2 times secant squared, or 2 times secant. But then I need to multiply by the derivative of secant as well. That's the third step in the chain rule. The derivative of secant is secant tangent. We have 2 factors of secant, combine them, and now we have our derivative of x with respect to t. We will also need the derivative of y with respect to t. But since y is just tangent, and the derivative of tangent is secant squared, we can immediately calculate that. Now that we have these 2 derivatives, we're going to need to combine them to find the derivative of y with respect to x. So let's get a little extra space. The derivative of y with respect to x is going to be the ratio of these 2 derivatives. You can remember this formula by imagining these dt's canceling, and then it would simplify to this. A better way of understanding what it means is to think about rates of change. Like if y is changing twice as fast as x, then the rate of change of y with respect to x will be 2. So we already calculated the numerator and denominator symbolically. Let's insert those 2 equations. dx dt importantly needs to go in the denominator, and the other goes in the numerator. Combining, we get secant squared of t over 2 secant squared times tangent. Therefore, we have a common factor of secant squared in the numerator and denominator, and those can cancel. After after canceling, we get that the derivative is equal to 1 over 2 tangent t. For any value of t that doesn't make this denominator 0. The slope of the tangent line that we want needs to correspond to the time t when we're at this point. That's the time t pi over 4. So now, to find the slope m, we're going to plug in pi over 4 into this t. That simplifies down to 1/2, because tangent of pi over 4 is 1. Let's go back to our formula, our point slope formula for our tangent line. Replace this value of m with 1/2. And we actually have an equation of the tangent line already. This would be a perfectly good answer. But let's just simplify it a little bit more. You can also write it in the slope-intercept form. You would just add the 1 to the other side and distribute this 1/2 and get this. Once it's in slope-intercept form, you can easily create the graph of this line. It's got a y-intercept of 1/2, and it's going to have a slope of 1/2. So this is what the graph of the tangent line looks like.